we should now be ready to do part B of this question. So part B of this question, I still have my 350-meter tall building. I still have acceleration as 9.8 because it's still just falling straight down because of gravity. And we have now, we want to know the velocity as the stone lands. V1 will still be 0 because it's still being dropped. So all of our information is the same. I'm just solving for something slightly different. That's all we're doing. So I should be able to do this pretty easily. Again, it's just about picking the right equation, right? It's about going up and picking the right equation and thinking about what I know. I'm going to keep using this information. I'm not using my 8.5. It might be wrong. I don't want to mess that up. I'm going to find V2 though instead. This is my other thing I'm calculating. I'm just calculating for something different. So I'm just going to pick a different equation, right? I'm going to pick this equation because this one has everything I have plus everything I need to know. So off I go. Oh, V2 is going to be nice and easy to do. This case, V2 squared, I've got 0 squared plus 2 times my positive 9.8 because it's speeding up as it falls, times the total distance it falls. Remember, we're ignoring air resistance because we can't deal with it quite yet, maybe in your future. So V2 squared is really easy to find, right? I'm going to pop this in my calculator. 2 times 9.8 times 350, and I get a nice big number. It should be a nice big number, right? Because it is the number squared, and it's falling a fairly big distance. So 6, 8, 6, 0. But that's V squared. I don't want V squared. I want to know V, right? So that means I need to take the square root of my number. And I only get 2 digits still, just like before. The 9.8 counts. So I get 82.8, which makes this 83 meters per second. That is pretty fast. Now, you should know you shouldn't drop rocks off of very tall buildings because it's dangerous. Why is it dangerous? Because you could hurt someone seriously because things get pretty fast in that kind of distance. So a nice therefore sense for the whole question. 8.5 seconds and has a velocity of 83 meters per second as it lands. Now, a lot of people say to me, this is great. Wait a minute. As it lands, once it lands, it's 0. Yes, that's after it lands. As it lands, it's going at its fastest possible speed it ever had, which in this case is 83 meters per second. After it lands, the ground will slow it down. That's why